Now let's examine RAID creation. And RAID features the ability to spread data across multiple disks, 2 or more. So data spread across 2 or more disks/partitions, and more importantly, redundancy. That is the ability to recover from catastrophe. And that's provided by RAID. Within Linux, a number of RAID versions or implementations are supported. So those are called levels, including 0, 1, 4, 5, 6, and 10, as well as some other features such as linear and container, among others. We'll look at the common types, 0, 1, and 5, that are implemented throughout data centers at the hardware as well as software levels. Now, of course, the software implementation of RAID is considered the poor man's RAID, by contrast to a dedicated card to provide this functionality, or even firmware type RAID built into the BIOS, let's say Intel RAID, for example. But nonetheless, the kernel is able to, software-wise of course, aggregate your storage and provide levels of redundancy that are compliant with the RAID spec. So we've got some tasks. One, and that is to set up RAID 0. And of course, before we can do so, we'll need to lay out our partitions to reflect the various sizes that are appropriate for RAID. So one will create multiple partitions so that we can create multiple RAID devices. Let's connect to our server and do that, since it typically requires a reboot, so that we can take some notes during the intermission, if you will. We'll SSH to 192.168.75.20, and then we'll fdisk list dev sdb to see what's going on there. There's some partitions defined that we'll clean up. Let's see SDC as well, and we can use parted to clean it up, fdisk to create it, or either or, doesn't matter. So let's go ahead and fdisk dev sdb, and this is where we will delete the partitions, run help for any options, just like with parted. Some of the options are similar, although in parted it's RM versus D for delete. So let's delete some partitions. Partition number 4, for example, and 3 as well as 2. We'll leave the LVM partition intact, and those partitions have been wiped. We should create some ancillary partitions for our various purposes. Since we're going to be creating 3 types of RAIDs, we should ensure that there are enough partitions to go around without having to clobber existing partitions to make way for the new ones. So, supposing we have, let's say, 2 for RAID 0, 2 for RAID 1, and 3 for RAID 5, that means we'll need 7 partitions. And we can do so using extended partitions by creating a logical partition, or as logical partitions within the extended partition. So to make a new partition, just type help, for example, and you'll see that the new partition option is N, and we can describe it as extended to use the rest of the disk. We can label it as partition, let's say, number 2, and use all of the cylinders that remain. So we'll start at 2432 and end at 4427, and that will cover the extended space. Now within the extended partition, we can create n number of logical partitions to suit our needs. So let's create a new partition, and we'll add it as a logical partition, 5 or over, starting at cylinder 2432. And for simplicity, perhaps we'll make each of these partitions 2 gigabytes. So that'll take us right up to the edge, since the LVM partition is about 20 gigabytes. So let's make this partition 2G. Let's print it, and that leaves us some space to define the others. The extended logical partitions within the extended partitions begin at SDB5. So, and it is traditional to create the extended partition as the fourth partition, leaving 3 for primary. Let's create a new one, and this will also be a logical partition, beginning at the default starting cylinder, and also being 2 gigs in size. And we'll create some more. This will be also 2 gigabytes in size. Let's see how many are there now. So we're looking at 5 through 7 or 3 partitions. We need a few more partitions. Now, we can spread our data across the 2 drives that are available. So we need a total of 7. And we can, let's say, mix and match from each, since we'll be doing 2-2 for mirroring and RAID 0. So for example, we'll take SDB5 and SDC5 to make RAID 0, SDC6 or SDB6 and SDC6 to make RAID 1, and then we'll need SDB7 and 2 other partitions to make RAID 5. So let's go ahead and create that new partition, and it'll default to also 2 gigabytes. The size is irrelevant. So now this gives us an extra partition. So 7 and 8 could be a part of the RAID set in conjunction with something on SDC. So let's go ahead and create on the other disk. We'll write the changes, and then of course it will require a reboot. Let's launch SDC and print the table. We'll delete partition 3 and partition 2 and create a new partition, extended, and we'll make it partition 2. And we'll start at 2432 and go to the last cylinder, 4427. And now let's create the logical partition. So we want the counterparts, SDC5. So the first logical will start at 2432 and will grow to 2 gigabytes. And the second logical, this doesn't support command history, redline support like parted. So the second logical will be SDC6, which will also be 2 gigabytes in size. And let's create another one, and it'll be 2 gigs as well. Let's print the table. So SDB2 and C2 will form RAID 0, or B5 that is, and C5. B6 and C6 will form RAID 1. The other 2 from B, so 7 and 8, and 7 from here will form RAID 5. But we can also include it now since it requires a reboot. So let's just define yet another partition, starting at 3218 and making it plus 2 gigabytes. And now we have an equal number of partitions. So let's save the changes in fdisk list dev SDC. We have 1 through 8, sans 3 and 4, and let's list B. Ditto 1 through 8, sans 3 and 4. So we have an equal number of partitions, all of type 83 Linux, and these will be available to create our RAID sets. So let's reboot the server so that the changes are committed. This will kick us off, and then we'll set up in our documentation what we're going to do. So create multiple partitions, dev SD, and we'll use a character class to define B and C, partitions 5 through 8. So this could also be defined using a character class, so 5 through 8. So those partitions are in place, and the next step for us is an init 6 to reboot the system. Once the system's back up, we need to define the RAID levels that are of interest, beginning with RAID 0. There's a key utility named mdadmin, which is a part of the mdadmin package, which is responsible for managing RAID devices. It operates in a number of modes, including but not limited to create, assemble, miscellaneous, and we will use the create mode to create devmd0, which is the traditional device name for the first RAID volume, with subsequent devices being incremented accordingly. We'll have to define the level, setting it to RAID 0. This is how we differentiate between 0, 1, 4, 5, 6, and 10. And then we'll also specify the RAID devices count to indicate the number of devices that will belong to this particular RAID set. And then we'll indicate dev SD, and we could use a character class or just list them individually. So dev SD B5 or dev SD B5, which is the first one, and dev SD C5 will make this RAID set. Once the RAID device has been created, we then need to overlay a file system. So at that point, we'll make 2FS type ext4 with journaling turned on dev MD0. Once a file system has been made, we'll create a mount point, so we'll make directory /RAID0, followed by a mount of dev MD0 in RAID 0. Then we'll wrap up by modifying the persistent file or the file system table file fstab. And then we'll move on to the other sets. So the next one will be RAID 1, which is largely a repeat of a process. So just to recap, similar to LVM, there are roughly 6-7 steps. Create the partitions of type 83. Let's just note of type 83 or type Linux, not swap or LVM. Reboot the system if necessary. Not all systems require reboot. You can try to see whether or not your kernel has detected the various partitions without error by examining the output. You may also use partprobe to see if you can force the kernel to detect the new partition tables on the various disks. Once the partitions are available, use mdadmin with the create option to create the RAID device out of the drives that are desirable. 2 or more, of course. By now our server should be up, and indeed it is. So before doing so, let's just fdisk list dev sdb, dev sdc, and notice that dev sdb contains 5 through 8 4 partitions, and ditto for dev sdc. So those partitions are in place. We can now create our RAID volume. So let's try to create it. And it started dev MD0 for us. Once you see that the device has been started, it means that mdadmin was successful in creating the particular dev tree entry out of the disks that are of interest to us. So in other words, it's worked. Now the next step for us is to overlay the file system on dev MD0 and mount it, see whether or not it's accessible, and then outline the other types. So our steps include make 2FS, which is one way of executing the creation of a file system on a device that's in the dev tree. So let's go ahead and make 2FS ext4 and dev MD0. And this will set things up for us. Let's echo the exit status to make sure that it's clean. Indeed. Then we will make a directory and mount the RAID 0 device or array in that particular directory. Let's echo the exit status, and of course mount will tell us whether or not things are clean. And indeed, it's up, read write, which means if we LSL RAID 0, we should see lost and found. And if we sequence some data to that directory, it should certainly work. So it's RAID 0, and this should be 100k seemingly .text. Indeed, we can write to it. So super, that's up RAID 0. And there are ways using mdadmin to query the RAID sets that have been defined. So no need for you to memorize what was made where, although it doesn't hurt to spreadsheet or document these items in a spreadsheet. So that's RAID 0. It's up. Now, because we've created all these partitions, everything's in place. Creating subsequent RAID types become even easier. So RAID 1, for example, instead of creating and initializing to level 6, which causes us to reboot, because the partitions are in place, we simply mdadmin create dev md1, which is the next value up, and that is traditionally used to describe RAID arrays 0, 1 through n, and this time the level is going to be set to 1. With the RAID devices being 2 or more, and an even number is desirable and required, so 2 devices, dev SDB6 and dev SDC6, will be the devices that are of interest. Again, there are short options for these long options here, like RAID devices, for example, etc. So this is the string that will make a new RAID device out of these 2 devices using RAID level 1. Again, RAID 1 is mirroring. So this is mirroring, and that means it halves the storage. So whatever you allocate, expect to benefit from half of the storage. So these 2 blocks are 2 gigabytes each for a total of 4, and if we were using RAID 0, we would have access to all 4 gigabytes sans redundancy. But because it's RAID 1, we will have access to half, which means we have redundancy, but lose half our storage. Now, of course, if you're working with larger order drives, like 2 terabytes, for example, especially with storage being so affordable nowadays, it's not such a big problem. So let's mdadmin to create this new item, and it'll say yes, it's seen information before. That's fine, we'll just override it because we have been mucking around with the partitions. And now dev md1 exists, which means the next step in the process is to overlay a file system using make 2fs type ext4, journaling turned on, dev md1, and that will overlay the file system for us. And we can even include everything in one command, but so that it's clear in our documentation, we'll just separate them as individual commands. So let's make 2fs type ext4 and dev md1, and there it writes the file system information, the inode information, so that we can write files to it. We'll then follow that up with a similar command, but this time it'll be RAID 1 instead of RAID 0. And let's go ahead and put this in place as step C. That's going to be make directory RAID 1 and mount dev md1. Now there's no hard set association between dev md1 and / RAID 1. You can mount these RAID devices wherever you see fit. It's up to you. But just to keep things sane, we'll keep with this nomenclature. So let's try to mount and echo the exit status. So mount should now reflect dev md1, indeed. So it's intact. And that means we can also write data. So sequence 1,000,000 to RAID 1 1,000,000.text. Just a quick way of dumping some data, or use DD with dev 0 or some other facility, doesn't matter. LSL dev md1, that's a device. RAID 1 is where it's mounted, and we can write to it. df-h shows that md1 reflects half the storage of the aggregate storage because it's mirroring. So that takes care of mirroring. And this will survive, of course, the failure of one of its members. So that's in place. And of course, we should also follow up with a modification to fstab. We'll do it after we finish the RAID 5 volume. So RAID 5, and this will be, of course, striping, which is like RAID 0 with parity. And this level sacrifices the equivalent of one drive or partition. The equivalent storage, that is. So mdadmin. Now we have 4 partitions available across 2 drives that we'd like to include as part of the RAID 5 set. So we'll create dev md2, setting the level equal to 5, and indicating that the RAID devices are dev, and the order is unimportant. You can specify them however you see fit, but dev SDB7, for example, dev SDB8, and similarly on the SDC disk, 7 and 8. We could use character classes as well. SDC8. This will include 4 disks, and the RAID devices needs to be set equal to a number of disks. Let's not omit this, equal 4. And this command will create a RAID 5 striping with parity array. So let's clear screen. And let's continue. Let's notice RAID level 5, part of an array, no problems there. DevMD2 has been created. That's fine because again we've made changes. So DevMD2 is in place. Let's overlay the ext4 file system. Make 2fs. Type ext4 devmd2. Overlays the file system, which will take a little bit more time because of the size differential compared to the mirrored item, but nonetheless will generate it rather quickly. More inodes because more storage, more blocks are available. So now we should see that devmd2 becomes available. While that runs, let's just set up the next command, and that is to make the directory RAID 5 and mount devmd2 in this directory called RAID 5. And then if that is successful, sequence 1,000,000 into RAID 5 1,000,000.text, and if that is successful, LSL RAID 5 to confirm that the items are there. And if all of that's successful, then we'll update etcfs tab and test that they all mount. So let's try this out. RAID 5, mount, so on, sequence, you name it, there it is. So mount should now show the RAID 5 volume mounted read-write. And df-h should show similarly. And at any time, if you needed to turn this into either of these volumes into a RAID or into a read-only device, you could just remount as read-only or use the mdadmin utility to mount read-only. So now we see that 6 gigs are available. Now, back to the notion of sacrificing the equivalent of one device. Each of the partitions that constitute this RAID 5 device is 2 gigabytes each. So 2 times 4 is 8, and we're sacrificing 1, so that gives us 6. So indeed, the equivalent of 1 disk has been sacrificed to construct the parity necessary to recover from the failure of one of the members of this RAID 5 array. So we've set up RAID 0 as well as RAID 1 as well as RAID 5. These are the popular RAID types that you'll find in the wild, but certainly there are many other forms of RAID, combinations of RAID that are available out there. Now, insofar as fstab is concerned, let's go ahead and update that. We'll simply position it in our tempfs section, so let's modify etcfstab. And in this region, we can include a comment, RAID devices, and include their dev tree location, devmd0 through 2. And this will be mounted to /RAID 0, and its type is ext4. Default options, we could also turn on user and group quotas if we'd like. Let's include it. Defaults, user quota, in the event that we decide to check back in on quotas at some other point, and the check order. Let's make it more even, and then we'll copy and paste this, or cut and paste this twice, relabeling MD 0 to 1, 0 to 2, RAID 0 to 1, 0 to 2, and the rest is intact. Let's just add some space so it's visible. So now, if we U-mount the items at the root, let's try to use character classes here, 0, 1, 5, echo the exit status, and then do mount, we should see that they're all gone, using, of course, character classes. And now if we mount -A, this should attempt to remount those items, and this reads RAID 2, so the mount point needs to be fixed. Let's renano, MD1 mounted, seemingly, and the mount point for this one should be 5, so the 2 of them mounted properly, 0 and 1, not 5. That was my mistake. So let's remount all, and then we should now see 0, 1, and 2 all up with quota support and ready to be accessed. And of course, another way to test this is just to be sure that the data still exists. So let's LSL RAID 0, 1, and 5 using character classes just to see that they still contain the original files. Indeed, 100, 1 million, 1 million are all intact. And of course, DFH / RAID 0, 1, 5 will reveal just those items, indicating their sizes. And again, with RAID 5, you sacrifice the equivalent of 1 disk, which is what we've mentioned. So ETCFS tab has been updated to reflect those changes. So these RAID arrays will be brought up once the system has been rebooted. Now, as mentioned, MDAdmin allows you to manage your RAID storage arrays, including extending the arrays in the event that you need more storage. For example, in the case of RAID 0, 1, or 5, you can extend the arrays, or perhaps take disks offline because you suspect data corruption or perhaps some sort of physically noticeable error due to, let's say, lights blinking in colors that they should not be blinking. And so you can use MDAdmin to take those items offline, providing you still have enough disks, let's say in the case of RAID 1 or RAID 5, to still allow the data to be accessible by your clientele. Then you can take things offline, fix them, replace them with, let's say, new SATA or otherwise disks, and put them back into production and rebuild the arrays accordingly, which will take some time, just like it does with hardware RAID, but nonetheless works similarly and reprovisions that storage in its optimal form. So again, the RAID support within the Linux kernel requires that you spread your data, your RAID array data, across 2 or more disks. Redundancy is provided in levels other than 0. A number of levels and features are supported. The common ones are 0, 1, and 5. With 0, it's like creating an LVM volume set. You simply aggregate storage and lump them together and present them as one coherent group. So we created multiple partitions to facilitate RAID, all of 2 gigabytes each. We rebooted the system and then used the MDAdmin utility with the create mode against devmd0 for the first item, set its level, included the devices, and then overlaid a file system. Once a file system was overlaid, we made a mount point, mounted it, confirmed it. We repeated that for RAIDs 1 and 5, changing the levels and the number of disks that are associated in the case of RAID 5, and then updated ETCFS tab as the final task, and tested auto mount. So test auto mount during system initialization. And once that's in place, your RAID's in place, and not until, of course, you experience trouble during the uptime or life cycle of your RAID device will you have to worry about the other feature sets. So next, what we'll look at includes management of these RAID arrays using the MDAdmin utility.